In this episode, we are focusing on a part of technical work that seems simple until a small mistake injures the technician, damages a device, or creates a failure that does not appear until later. New learners often picture support work as mostly knowledge, diagnosis, and replacing parts, but the physical side of the job matters just as much as the thinking side. A careful technician pays attention to how equipment is touched, moved, opened, stored, and returned to service, because the body, the workspace, and the device all affect the outcome. Static discharge can damage delicate components without leaving obvious marks. Poor lifting can hurt a back or shoulder. Sloppy storage can turn good parts into bad ones, and rushed repair habits can cause more problems than the original fault. Good safety practice is not separate from good technical practice. It is part of what makes support work professional, repeatable, and trustworthy, especially in environments where one careless moment can create an expensive repair, an avoidable injury, or a confusing repeat incident a few days later. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at CyberAuthor.me in the Bare Metal Study Guide series. One of the first ideas to understand is electrostatic discharge, ESD, which refers to the sudden transfer of static electricity from one object to another. People cannot always feel it, hear it, or see it, and that is part of what makes it dangerous in support work. A tiny discharge that seems meaningless to a human body can be enough to damage sensitive electronic components inside a laptop, desktop, mobile device, or expansion card. Sometimes the damage is immediate and obvious, but sometimes it weakens a component so the device fails later, which makes troubleshooting harder because the cause is no longer easy to spot. That delayed effect is one reason disciplined handling matters so much. A beginner might think static risk is exaggerated because nothing dramatic happens in the moment, yet experienced technicians know that invisible damage is still damage. Safe repair work starts with respecting the fact that some of the most harmful mistakes are the ones that leave no obvious sign at the time they occur. Grounding is one of the main ways technicians reduce ESD risk, and the core idea is very simple even if the environment varies. If static electricity can build up on the body, clothing, or objects in the workspace, then the technician needs a controlled way to reduce that buildup before touching sensitive parts. Grounding helps equalize electrical potential so there is less chance of a damaging discharge between the technician and the device. This is why repair environments often emphasize anti-static work surfaces, proper grounding methods, and consistent habits rather than occasional caution. A safe approach is not based on touching one metal object once and assuming the risk is gone for the rest of the task. Movement, friction, fabric, chairs, and even dry air can allow static to build again. Good technicians treat grounding as part of the work process from start to finish. That means thinking about the whole repair session, not just the first few seconds before opening the case or lifting a component from its packaging. The workspace itself also matters because static risk and physical handling problems often begin before the device is even opened. A cluttered, unstable, or improvised work area invites mistakes, especially when the technician is tired, rushed, or trying to balance equipment in awkward positions. A good work surface is clean, stable, and large enough to support both the device and any parts that need to be removed temporarily. That may sound basic, but many avoidable accidents happen because screws roll away, components are set on unsafe surfaces, or a device is placed too close to an edge where it can slip or fall. The technician also needs to be aware of clothing, packaging materials, and nearby objects that may increase static risk or physical interference. Good discipline begins before disassembly by creating a workspace that supports careful work instead of fighting against it. A stable environment reduces distraction, protects small components from careless handling, and makes it easier for the technician to focus on safe movement, safe contact, and controlled repair steps. Lifting safety is another area where beginners sometimes assume common sense is enough. Yet many injuries happen during routine movement of equipment rather than during dramatic accidents. Support work can involve lifting desktops, monitors, printers, battery backups, small servers, and boxes of replacement equipment, and not all of those items are shaped in ways that make them easy to handle. A technician who lifts with a twisted back, reaches too far, or tries to prove strength instead of using judgment can create a strain that lasts long after the repair is forgotten. Safe lifting means thinking about weight, shape, balance, path of movement, and where the item will be set down before the lift begins. It also means using the legs and core more than the back, keeping the load close to the body, and avoiding sudden turns while holding awkward equipment. A moment of planning is often the difference between a smooth move and an injury. Good technicians do not treat lifting as separate from support work. They see it as one of the physical skills that keeps them able to keep doing the job. Another important part of lifting discipline is knowing when not to lift alone. Pride, haste, and habit can all push people into poor decisions, especially when the device does not look especially heavy at first glance. But size, balance, sharp edges, and fragile construction can make equipment risky even when the total weight seems manageable. A large printer, a monitor with a weak grip point, or a system unit packed with components may shift unexpectedly during movement, and that sudden shift can injure the technician or damage the device. Asking for help, using proper moving equipment, or breaking the task into smaller stages is not weakness. It is professional judgment. Good support work is full of moments where the safest choice is also the smartest operational choice, because avoiding injury and equipment damage saves far more time than any rushed move ever saves. A technician who thinks ahead about doorways, stairs, cables underfoot, and where the equipment is going to land is already working more safely than the person who focuses only on getting the item off the floor as fast as possible. Storage discipline is another quiet part of support work that has long-term consequences. Parts that are stored poorly may still look fine from the outside, which can create false confidence until they are installed and fail. Devices waiting for service can also be damaged by careless stacking, unstable placement, rough contact, or exposure to conditions that the technician did not think much about at the time. Good storage means keeping components in appropriate protective packaging, separating items so they are not crushed or scratched, and labeling them clearly enough that the team knows what they are, where they came from, and whether they are ready for reuse. This is especially important for memory modules, drives, cards, cables, batteries, and small internal parts that can be mixed up easily during busy support periods. A repair bench that turns into a temporary junk pile is dangerous because it confuses good parts with bad ones and clean parts with questionable ones. Storage discipline protects value, supports accurate repair work, and helps the team avoid turning inventory into mystery. Careful storage also protects chain of ownership and repair accuracy in everyday operations. If a technician removes parts from a device and places them in random locations, the chance of mixing devices, losing parts, or reinstalling the wrong item rises quickly. Even when the parts appear similar, model differences, firmware variations, or patterns, or user-specific issues can make correct tracking important. A disciplined technician keeps removed components organized in a way that supports reassembly, return decisions, and later explanation if something needs to be reviewed. This matters for the device, but it also matters for the technician, because clear organization protects against blame and confusion. When people can see what was removed, what was replaced, and what was preserved, repair work becomes easier to trust. Good storage habits also reduce accidental contamination from dust, moisture, spills, and contact damage while parts wait for the next step. Support work often happens under time pressure, but the technician who remains organized under pressure is usually the one who creates fewer repeat problems and finishes with more reliable results. Repair discipline starts before the first screw is removed because safe work depends on preparation, not improvisation. A disciplined technician confirms the problem, understands what area of the device is likely involved, powers down appropriately, disconnects what should be disconnected, and approaches disassembly with a plan instead of curiosity alone. This reduces the chance of pulling apart sections of a device that do not need to be disturbed and lowers the risk of damaging cables, clips, connectors, or housings through unnecessary force. New learners sometimes think confidence means moving quickly, but experienced technicians often move carefully and deliberately because they know how easy it is to turn a minor repair into a major one. Repair discipline also includes keeping track of fasteners and understanding that devices are often built with parts that are similar in appearance but not identical in roll or length. A misplaced or incorrect fastener can damage internal layers, put pressure where it does not belong, or weaken the reassembled device. Slow, organized handling is often faster in the long run because it prevents avoidable mistakes. Handling internal components safely requires the technician to control both movement and contact. Sensitive parts should not be grabbed by delicate surfaces, pressed unnecessarily, or flexed because the technician is impatient or trying to create space where there is none. Connectors, ribbon cables, batteries, and small mounting points often fail not because the device was defective, but because someone used more force than the part was designed to tolerate. Good handling means recognizing that modern devices are often compact and lightly built, with very little margin for rough contact. It also means supporting a device properly as it is opened so that hinges, screens, covers, and internal cables are not placed under strain. A technician should be aware of where pressure is being applied at all times. If a part does not move as expected, that is usually a sign to stop and reassess rather than push harder. Physical repair work rewards patience. The person who notices resistance, alignment, and fragility will protect the device much better than the person who assumes that every part will yield if enough pressure is applied. Battery awareness is also part of repair safety because modern devices often contain power sources that deserve careful handling even when the system appears turned off. A swollen, punctured, bent, or overheated battery can present a very different level of risk than an ordinary component, and the technician should treat unusual battery condition as a warning sign rather than as a minor inconvenience. Even without a dramatic event, poor battery handling can damage the device, create safety hazards, or complicate the repair further. More broadly, any component that stores energy or becomes hot in normal operation deserves extra respect during support work. A thoughtful technician gives hardware time to cool when needed, avoids careless contact with areas that may retain heat, and never treats internal power-related components as harmless simply because they are small. Support work is safest when the technician remembers that electronics are physical systems, not just logic problems. Heat, pressure, sharp edges, stored energy, and fragile materials all exist at the same time, and good repair habits require awareness of each. Another part of safe physical work is protecting the device from unnecessary exposure while it is open or waiting for service. An open system is more vulnerable than a closed one because internal components, connectors, and surfaces are less protected from contact and contamination. A disciplined technician does not leave a half-open device where it can be bumped, where liquids might reach it, or where other items can be set on top of it absent-mindedly. The same discipline applies to removed covers, screens, and accessories, which should be placed in a way that avoids bending, scratching, or losing alignment pieces. Good technicians also think about reassembly from the beginning. They do not want to finish the main repair only to discover that they handled cosmetic panels poorly, left cables pinched, or forgot how the device was originally routed and supported. Physical discipline is often about protecting the future state of the device while the repair is still in progress. That is what makes the final result look and function like a professional repair rather than a hurried intervention. Many beginner mistakes come from misunderstanding what careful work looks like. Some people think safe work is mainly about having the right equipment nearby, when in reality habits and judgment matter just as much. Others assume that if a device powers on after the repair, then the physical handling must have been fine, even though hidden damage, weakened connectors, or poor internal routing may create problems later. Some learners also confuse speed with competence and feel pressure to get through disassembly quickly to prove they know what they are doing. But support environments do not reward damage that comes from rushing. They reward repeatable results, protected equipment, and technicians who can work carefully even when a problem seems familiar. Another common mistake is becoming casual with routine tasks. The fact that a person has moved many desktops or opened many laptops does not mean the next one will forgive sloppy handling. Safety discipline is not a special mode reserved for difficult repairs. It is the normal way responsible technicians work every day. Over time, these habits shape professional identity just as much as technical knowledge does. A technician who grounds properly, lifts intelligently, stores parts carefully, and handles repairs with discipline becomes someone other people trust with valuable systems. That trust matters because support work often happens around expensive equipment, business-critical devices, and users who may already be stressed by the problem they are experiencing. Calm, careful physical work lowers the chance of making the situation worse and shows respect for both the organization and the user. It also protects the technician's own long-term health, which is easy to forget when people focus only on the immediate ticket or repair request. The body is part of the job, and repeated poor lifting or careless movement can build real injury over time. Safe work habits do not only prevent dramatic accidents. They preserve the technician's ability to keep working well month after month and year after year while delivering better outcomes for the devices being serviced. By the end of this topic, the main lesson to keep in mind is that disciplined physical work is not just an extra layer around technical support. It is part of technical support itself. ESD awareness protects sensitive electronics from invisible damage. Grounding reduces avoidable risk. Safe lifting protects the technician from injury. Good storage protects devices and parts from confusion and harm. And careful repair discipline prevents small issues from becoming larger failures. These habits may look quiet compared with troubleshooting logic or replacing a failed component, but they are often what separates clean, reliable work from expensive, frustrating rework. A strong technician learns to respect the device, the workspace, and the physical limits of the human body at the same time. When those habits become normal, support work becomes safer, more consistent, and more professional. That is the real value of this topic, because it teaches that careful handling is not a delay in the repair process. It is one of the reasons the repair succeeds.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.